Just like RDBMS, Hive supports joins too. So Hive has inner join, left outer join, right outer join. The HQL statement for joins in Hive is exactly similar to that of SQL. So you select from two different tables, table A and table B, and then you mention the join column like a.id equal to b.id and a.department equal to b.department. Similarly, you write left outer join and then followed by the join column. You can join multiple tables also, just like this. Again, I mean, this is the clause wherein you are mentioning join statement specifically, but you can mention select a dot val, b dot val, c dot val from a comma b comma c, where a dot key equal to b dot key 1 c and c dot key equal to b dot key 2. That is another syntax which you can use without mentioning the join keyword. Let's talk about some of the Hive configuration parameters. I have shown you a few of them, not all. There are a lot of Hive configuration parameters. In the resources section in the Hive commands document, I have pasted the link where you'll find all these configuration statements. I'll talk a few of them. The first one is Hive map reduce mode strict. You already know what is this. If you set Hive map reduce mode to strict, full table scans are rejected, and also if you mention order by, it would need a limit clause. There are some other parameters like Hive exec parallel. So using, if you mention true, then what will happen is that Hive will execute the jobs in parallel. You can also mention the parallel thread number, how many jobs can run in parallel. We have already seen enforced bucketing. Hive exec dynamic partition to true will enable the dynamic partitioning, and also we have Hive exec dynamic partition mode to strict and no strict. Typically we mention no strict. We also have seen Hive exec mode local auto. If you set it to true, then if you run a select statement, then the select statement will fetch the record directly by reading from the file rather than running any MapReduce or these tasks. There are a few other execution parameters like Hive exec temporary table storage. We have not talked too much about temporary tables. It mentions the storage policy for a temporary table. Then there's something called Hive default surday or serializer and deserializer. By default, it is a lazy simple surday, which is essentially the surday for text file and RC file. The default file format is also set as text file. You can change it to sequence file, RC file, ORC, or Parquet. We have already seen Hive metastore warehouse directory multiple times. This is the location of the database or the tables inside of the database where you database and table should be stored. We have not seen this Hive execution engine. So it is mainly true for self-managed Hive. You can mention the execution engine to be MapReduce or These or Spark. In case of EMR, it is set as These because that is the default execution engine. There are other execution engines also like MapReduce and Spark. Then using MapReduce reduce tasks, you can mention the number of reduced tasks per job. It becomes more useful when you run Hive when you want to specify a specific number of reduced tasks. We have a configuration called Hive merge these files equal to true. It will tell you whether to merge the small files at the end of a trace tag. All these parameters relate to transaction manager or Hive transaction or asset transactions. The first one is Hive transaction manager, and you have to mention it as Hive QL log manager DB transaction manager. It will turn on the Hive transactions. I talked about compaction in Hive transactions. So compaction is a background asynchronous process which merges multiple delta files or delta files and base files together. So Hive compactor initiator, compactor cleaner, compactor worker threads, etc. are all related to the compaction process. Hive support concurrency true. So it talks about whether Hive supports concurrency or not. This is also needed for transactions. Then enforce bucketing and exec dynamic partition mode to be non-strict. These two has to be set as is for transactions. And finally, we'll have Hive lock manager to be set up as zookeeper. So all these configuration parameters are needed for transactions. Finally, I'm showing you some configuration parameters for Hive web interface, the WAR file for web interface, the listener host and the listener port. So where all these configuration parameters are stored. So if you run self-managed Hive, or let's say you are not using EMR and you want to install Hive on an EC2 machine or your own laptop or a server on-premise, all these configuration parameters are stored in something called Hive site.xml. So this is where the configuration parameters are stored. In EMR, you have already seen that we can actually install multiple applications. It might not be logical to create configuration files for each of those applications. So instead of that, EMR gives us an option of configuring it using the AWS console itself. That configuration can be provided by supplying a configuration object, which is nothing but a JSON file. Again, you can provide a JSON file or you can provide the configuration parameters while creating the cluster, or we can modify the parameters later on also. There are two components of the configuration object. One is classification and the other one is properties. So this is how it looks like. Classification is basically the application file name where you mention the parameters. So in this case, mapreduce site is equal to mapreduce site.xml. For Hive, it will be hive-site. And in the properties, we'll mention all the configuration parameters and its corresponding values. So far what we have done, we have used this set command to configure the parameters and its corresponding values. We have not done it permanently. So every time we came out of the Hive session, the value of the configuration parameter went away. For example, Hive metastore MapReduce, I had to set it to S3 every time I started a Hive session. But we can change it using this configuration parameter. For Hive, in the classification, we'll mention Hive-site, and in the properties, we'll mention all those configuration parameters and its corresponding values that we want. So classification maps to application-specific configuration file. As I said, Hive-site classification would map to hive-site.xml configuration. In this case, mapread-site is mapping to mapreduce site.xml. We have also core-site, which is mapping to core site.xml file. So let's have a small demo and see how we can configure it for EMR. So I'm launching an EMR cluster. The name of the cluster is DEMR cluster Hive, and all the application parameters are similar to that I had mentioned in the first time. So I'm not going to show you each and every setup. I'll scroll down and there's this software settings parameter, and this is where you mention the configuration parameters. There are two ways you can do it. You can mention the configuration parameter here itself, or you can load it from a JSON file which is stored in Amazon S3. I have not stored any JSON file in S3. What I'll do is that I will provide the configuration parameters and its value here itself. So in the classification, I'm mentioning that it will be a Hive site classification. The purpose of this is that it will map to hivesite.xml. And in the properties, I'll have to mention all the configuration parameters and its corresponding value. For example, Hive metastore warehouse directory, I'm mentioning to be the S3 bucket, which I've been using so far. I'll also mention the configuration parameters for dynamic partitioning. So I have set up only these three parameters. One is the metastore warehouse directory and then the parameters for dynamic partitioning. Let me go ahead and launch the cluster. I am in the primary node of the cluster. Now if I type Hive, it should open a new session. In the new session, I'll see what is this Hive metastore warehouse directory is set to. So if you see, it has been set to the S3 location that I had mentioned in the configuration object while creating the cluster. Similarly, I had set the dynamic partition to true also. So as I had set only two parameters, I am showing you two parameters. Obviously, when you launch the cluster, you can mention as many parameters as you want so that you do not have to change it every time while launching the EMR cluster. Now I'll come out of this session and start it one more time, and to show you that the value of the parameter configuration parameters like Hive metastore warehouse directory and Hive exec dynamic partition would not change even if we start a new session. So Hive metastore warehouse directory is still set to the S3 location, and Hive exec dynamic partition is still set to true. If you are from RDBMS or application background, you know that databases acquire logs when you run certain statements on it. Hive also behaves like databases, and Hive also has some log modes. But the log modes in Hive are pretty straightforward. There are only two types of log modes. The first one is shared log. Shared log is taken while we are reading data from a particular table, and in all the other operations, exclusive log is taken. So this is the log compatibility chart. Here we have existing log shared and exclusive, and here I am mentioning requested log, which is also shared and exclusive. So if you see, only shared log is compatible with other shared logs, meaning if you are running select statements, you can run other select statements on the same table, but you cannot run any other statement on that particular table, because all those other operations will take exclusive log. So if you have exclusive log, you cannot take shared log. If you have shared log, you cannot take exclusive log. And obviously, exclusive log is not compatible with exclusive log. Now, this is a very nice table which I have taken from open source Hive documentation. So on the left hand side, we have Hive command, and on the right hand side, it mentions the logs that are acquired for those commands. So in the first case, it is showing select statement from a table on a partition. So if you see, it will take a shared log on the table and also on the partition. If you are running insert statement on a particular partition P2, when you are selecting row from separate table on partition P1, so it will take shared log on T2, T1 and partition 1 of T1, but it will take exclusive log on partition P2 of table T2. You can pause this video and take a look at all the logs that are acquired for individual or for different Hive commands or HQL statements. We have something called Hive storage handlers also, and Hive storage handlers are used to connect to NoSQL databases like HBase, Cassandra, DynamoDB, etc. So the storage handler has multiple components like custom input format, custom output format, and custom serde. The default file formats like Parquet, ORC, etc. cannot be used for storage handlers because the input and output format would be different for NoSQL databases than the file formats we have been using so far. This storage handler will talk to the NoSQL database storage system, which eventually will talk to the NoSQL database. If you want to use Hive with HBase, so we will have to create an external table with stored by as HBase storage handler, and we'll have to mention some table properties. Similarly, we'll have to create an external table for Cassandra also, wherein we'll mention stored by as Cassandra storage handler, and in the serde properties, we'll do the column mappings. For DynamoDB also, we'll be creating an external table wherein the stored by format would be DynamoDB storage handler, and column mapping is done in table properties. I'll not show you all of them, but I'll show you the integration between Hive and HBase using HBase storage handler. So what are the various integrations that Hive provides? I have already told you about HBase, Cassandra and DynamoDB. There are some other big data frameworks also like Druid and Kudu, which has integration with Hive. And one of the important integrations is Spark. We have seen MapReduce and Tez as an execution engine on top of Hive. Spark can also be used as an execution engine for Hive queries. That's all about Hive. Thank you. We'll see you in the next video.